but we're going to do it in a way that allows us to identify the specific virus and, as I'll show you, will allow us to respond to new viruses. So what we need then is a rapid diagnostic for the identification of influenza subtype in point of care. Is it a seasonal or is it a pandemic? Again, existing rapid tests are unreliable. In fact, their statistics are absolutely awful. In many cases, their false positive, false negative rates can approach 50%, which means you might as well just throw a dart at the board. You're going to get about as good an answer. And they do not provide subtype information. So our goal with this product then is to provide a product that does have very good statistics, provides very useful information, and actually won't be economically much different than the current quick tests. Well, why do we need or why do we even want this product? It's relevant to any of you who have to present. And that is, what are the outcomes? So if you can ID the known strain and do so in a high throughput manner, so when you have a high patient load, it directs the treatment choices the physician can use. It prevents antibiotic overuse, which then reduces the number of bacteria that become antibiotic resistant that then lead to secondary infections after the flu. It prevents central lab overloads, so the more critical patients still can be treated. And it improves overall health outcomes. If you can also identify that if there's a new strain coming through the system, you can implement containment measures, potentially leading to a pandemic, not turning into a pandemic. In fact, the very first H1N1 individual has been identified in Mexico City about a year ago. So if that had been quickly enough identified, or if it had been identified when there were only 3 or 4 people who were infected, the pandemic would have stalled before it started. So you can actually prevent pandemic if you have early warning. As a flow scheme, so I'm a scientist, I have to have a flow scheme in here somewhere. You're lucky I don't have a whiteboard, or we'd be here a lot longer. But why do you need a triage test? So just in a flow scheme form, it's not a virus, and it can be treated with an antibiotic. If it's not a flu virus, that dictates a particular kind of treatment. If it's a flu virus and it's a no strain, the subtype informs the treatment choices, avoids overloading central labs. It's an unknown strain, can be an alert to Centers for Disease Control, and go into containment mode. Well, we've decided that we want to have a triage system, but the question is how to build one that's efficient. So you start with a sample. Well, the first thing you need to do, is there a virus present in the sample? A lot of samples may not have a virus. They might have a microbe, or the person may have an allergic reaction to something. Secondly, is it a flu or pandemic virus? Yes, no. And then finally, getting down to identification. Well, do you want to take a sample and run first one test, and then another one, and then do you have to do 7 different tests to decide which H1, HX, and Y it is? The answer to that is obviously no. So what we're focused on is building a multi-target or multiplexed diagnostic. I'll show you how that's going to work in a second, but the idea here is that the sample won't give a single yes-no answer. It'll give a fingerprint for that sample, which can then be used to identify the appropriate agent that's in there. So the way this is actually done, and I could ask for volunteers for the nasal swab, but if you ever had one, you wouldn't volunteer anytime soon. But a nasal swab is taken, nasal pharyngeal swab as it's called, at the back of the sinuses. That's dipped into a simple tube environment. I do have a demo I'm going to give you in a minute. And then a simple reader, very easily capable for a point of care or clinical lab situation, will then have a readout. And it won't read out with this multiplexed response, which I'll explain in a second. It'll have a simple readout. It'll just say, yes, it's a flu virus, no, it's not a flu virus, and which one it is, giving direct and immediate information. The way it'll do this, and I think I'll do this actually in the next slide, is this is the sample that's been taken. This is whatever the virus might be. Our receptors technology then, just like you saw with glucose, has a competitive surface, or a binding surface. It's got a competitor agent, but it's got a series of them instead of just one. So it's got 4 in this case. Each one is a different color, if you will. We're obviously going to be using something different than straight color. We'll use fluorescence, but in this case, it's easier to visualize as color. So if a particular virus strain comes in, it will release into the solution where it can be read varying amounts of each of, for example, the 4 different colors. And that pattern will tell you that in this case, as an example, it's H1N1. Another pattern would tell you, say, and again, these are just examples, but if you saw this pattern inside the instrument, the user again wouldn't see it, this might be H3N2, seasonal flu. And as importantly, where I want you to think about is if the pattern now is unique, but you know it's a flu virus from the initial part of the test, you can alert to a new virus coming through, but you also already have the diagnostic for it because you've got the new pattern. And once then the statistics are established for that pattern, then the product and the device are already capable of whether it be a pandemic from, as I say, a bio-attack from Mother Nature, or whether it be a bio-attack from some other organization. So right now, we're in phase 1, proof of principle. We're building the sensing system. Again, it's rather similar to the glucose work, so we're not starting from scratch. We have our workflows in place. We're building the different materials even as I speak. And what we'll do is demonstrate the actual functioning of the system, and then in phase 2, so proof of principle in phase 2 will go on to prototype. So as I promised, a short demo with an assistant even. Bill will turn on the light. That's you. I'm not going to stick this wonderful device up Allison's nose, which I'm sure would not be fun for anyone. So if anyone has never seen one, this is a nasal pharyngeal swab, and that's about how far they put it up. It goes to the back of the sinus. That's why I'm not asking for volunteers. Oh, Pokey, I could. So this is a model sample that it would come up with. The way the test will be designed is it will immediately show that the test has started to work, and then as it's mixed, over about 20 seconds, it will tell you that the test is done, and this positive will tell you that it is in fact an influenza, and a stop reagent will be added into the reader, and then the readout will be, as I indicated, yes, no, H1N1, whatever the case might be. It's a very simple test, but built around our technology to make it very robust. Thank you. That wasn't even too painful. So in graphic form, then sample into the tube, into the sensor, and what's the result? So it matches the current clinical workflows for how people do these tests. And this kind of simple instrumentation is very, very common within clinics already. It just needs its own software. That's it for me.
Well, yeah, sure. I've seen that presentation about 10 times now.